Hi, Assalamualaikum warahmatullahi wabarakatuh. In this video, we're going to look at some examples related to solving questions with exponent. Yeah, and when you have any algebraic expression, the rules given in the previous chapter will still apply with this additional step that we have over here, which is this one. Okay. So what we have to do is whenever you have this algebraic expression, you always work from left to right, and as what you have seen previously, you will solve whatever there is in the innermost round brackets, and then you will consider solving expressions that are related to exponents or radicals. Next, you will perform multiplications or divisions, whichever comes first. And then finally, you will perform either addition or subtraction, again, whichever that comes first. Now, application of the concept of exponent here can be seen when you want to convert numbers in standard form to scientific form, for example. So what is a number in scientific notation? Well, the number in scientific notation has this form. So the first one here is you're going to write a number that is at least 1, and it has to be less than 10. So this is the first component of the scientific notation, a number in scientific notation, where you're going to write a number that is at least 1 and less than 10. And then the second component for a number in scientific notation is this one. You will multiply this with the second component, which is a power of 10. Well, you will see example of this later on, so don't worry too much about it. Now, as an example, this is helpful because when you have a very big number or a very small number, then you can write it in a compact form. So instead of writing such a long number that looks like this, then you can write it in terms of this one. So it looks more compact and easier to write, compared to doing it in this way. So the same thing with this one. This is such a small number, and what you can do is you can write it in terms of 4.2 times 10 to the power of negative 7. So it looks neater, it looks tidy. Okay, right. Now let us try and solve some examples related to algebraic expression that has exponents in it. Okay, now we are going to simplify and write the result using only positive exponents. That means all the negative exponents that you see over here somehow have to be removed, and we're just going to make sure everything here is positive. Okay, right, so let's start with the first question here. Okay, so this is the first question. So what we have is 2 to the power of 2, x to the power of 6, y, this is negative 3, w to the power of 4, and then we have over here all the expression, and I'm just going to simplify that to something that looks like this. 2 to the power of 2 is 4, x to the power of 6, y, and negative 3 over here is actually 1 over y to the power of 3. Yeah, and then we have w to the power of 4. So this is the first expression on top here, and then divided with this expression. So what we have here is, I'm going to write it in terms of multiplying with that expression, so it will be times 1 over, so this one is 3 and negative 3, so we know that based on the law of exponent, this is going to be written as 3 to the power of 3. Yeah. Similarly for this one, based on the law of exponent, we know that this is just 1 over x squared, and then we have y to the power of 8, and for this one it's going to be 1 w to the power of 6. Right, next we have 4x to the power of 6, w to the power of 4. So y over 3, I can just replace it over here. so it looks nicer like that. And then I know that this is going to be 1 over 27, 1 over x squared, y to the power of 8, 1 w to the power of 6. And then I'm going to change the outlook over here, this term over here. So it's going to look like this. It's going to be 4 x to the power of 6, w to the power of 4, y over 3 to the power of 3. And here is going to be 27 over 1. This is something that you have seen in the previous chapter. So 1 over 127 is going to be 27 over 1, x squared over 1, and then we have w to the power of 6 over 1, and you're going to multiply that with 1, y to the power of 8. So this guy over here. Okay, then what we have to do is we're just going to multiply the common terms. So for example, 4 times 27, we're going to get 108. So this one is done. Now we have x over here, x to the power of 6, x to the power of 2. If you combine these two terms over here, you will get x to the power of 8. Next, you have w to the power of 4 with w to the power of 6, so you get w to the power of 10. And finally, at the bottom part, you have these two guys over here, so it becomes y to the power of 11. So this is the answer for question A, where you can see that all the exponents here are positive. Okay, so this is what the question wants us to do, which is to turn everything here into positive exponents. All right, now let's move on and try to solve question B. Okay, I'm just going to erase this slide. All right, next is question B. So here we have a y z negative 1 plus y negative 1 z, and this can be written when you have a negative 1 exponent here. It means it will be just like y times 1 to the power of z 1. Yeah, so this is how you can change when you have a negative exponent. So this is the same thing as 1 over z to the power of 1, so which is 1 over z really. And then for this one, similarly, we can have that to be equal to 1 over y to the power of 1, and this is z. So again, to the power of 1 is z and just y. Yeah, okay, you can just erase that. Now so we can see that the term here is different, so we need to find that common denominator if you want to add up this expression we have here. So what we have is we are going to multiply these two together, so we've got zy, and then y will be multiplied with this one, so we got y squared plus z is going over that side, so we got z squared. So this is the final answer for question B, and you can see that all the exponents given here are positive. Okay, now let's move on to question C. Okay, so for this one, again, you can see that there is a negative exponent over here. So if you want to change it to a positive value, really we are going to just take the whole thing and we put it in under 1 over this stuff. For example, if you have a to the power of negative x, so what we're going to do is we're just going to take 1 over a to the power of x. So this is what we are going to do. We're going to take the whole thing here and put it under this bar. So we have 1 over 2x negative 2 y 4 z0 to the power of 4. So now we have turned this negative exponent into a positive value. So next, what we're going to do is we're going to simplify the denominator, and what we have is 1 over 2. So again, if you want to make sure that this negative exponent becomes positive, it is just times 1 over x to the power of 2, y to the power of 4, z to the power of 0, and this is exponent with the value of 4. Now, according to the rule of exponent, we know that if you want to get rid of this exponent outside, you can multiply, you can consider this as 2 to the power of 4. So we're going to do that. So it becomes 2 to the power of 4 1 over x squared to the power of 4, y to the power of 4 with 4, it becomes y 16. Z 0 times 4 is 0 still. Okay, so we have taking out this bracket over here. Next, we can simplify that. 2 to the power of 4 is 16, so 16 over here. This one is going to be 1 over x to the power of 8. Yeah, and this is y to the power of 16, and z to the power of 0 is going to be equal to 1, so we can write it down. So 1. Next, what we can do is we can change this outlook. So if you want to change this outlook, it's going to be 1 over 16 y to the power of 16. And then if you want to change this, it is the same thing as multiplying with x to the power of 8 over 1. And then final answer, we can just write it as x to the power of 8, 16, y to the power of 16. Okay, so that's it for the first example, example 3.2. Now let's move on to the next question. Without using the calculator, we are going to multiply these two values here and express the answer in terms of scientific notation. Remember, what is scientific notation? We're going to have one value here, which is where the number is at least 1 and less than 10. So that's the first component. And then the second component here is going to be a power of 10. So it's going to be multiplied with a power of 10. Okay, so without using the calculator, this is quite easy. So what we're going to do is, since they are all just multiplying with each other, we can rearrange the position so that it looks easier to be solved. Yeah, so I'm going to rearrange the position, all these things. So what we have is, originally we have 3 times 10 negative 4 times 12 and then times 10 to the power of 7. So I'm just going to rearrange the position. So we have 3 times 12, and then I'm going to have 10 negative 4, 10 to the power of 7. And we can see that these two terms here can be simplified. These two terms here can be easily multiplied. So this becomes 3 times 12 is 36. And then 10 to the power of negative 7 with multiplied with 10 to the power of 10 to the power of negative 4 multiplied with 10 to the power of 7. So that is reduced to 10 to the power of 3. Yeah. Next, what we have is, you can see that the first component here, the number given here, is greater than 10. So we don't want that. We have to make sure the number here is at least 1 and less than 10. So we're going to change this. We know that 36 is actually the same thing as 3.6 times 10, right? So if you have 3.6 times 10, you will get 36. So I'm just substituting 36 with 3.6 times 10 and times 10 to the power of 3. So this guy over here with this guy over here, 36 is substituted with 3.6 times 10. And then we're going to simplify that by combining 10 with 10 to the power of 3. So the answer is going to be 3.6 times 10 to the power of 4. So that is the final answer. Okay, next we are going to try and solve this question. We're going to write it in terms of the standard form. So this is already the scientific notation. Now we're going to change it to the standard form. This is a little trick which I have learned many years ago. So if you have 2.41 times 10 to the power of 6, in order to easily get the number, we're just going to move the decimal point on the right direction because the exponent here is positive. So if we have 2.41 times 10 to the power of 6, the number here is positive. So we're going to move this decimal point to the right direction 6 times. So we're going to move it 6 times. So 1, 2, 3, 4, 5, 6. So the decimal here from this position is going to be moved to this position. And I'm going to just fill up this space here with zeros. So actually the final answer here is going to be when you multiply 2.541 to the with 10 to the power of 6, the answer here is just going to be this value. So the decimal here is moved to this side. So the answer for this one is going to be 2 million and 410,000. Yeah, so that's the answer for the question here. Okay, thank you very much for watching, and I'll see you in the next video.